So yesterday we looked at tables and talked about how to write non-proportional equations from them. And so today we're going to look at graphs and talk about how to write non-proportional equations, focusing on the same pieces we've been going over in tables and in verbal descriptions, but now just finding them in a graph. So they want us to write an equation for the line represented in this graph. And so I remember that for a proportional graph, it had to be a straight line and go through the origin or go through 0, 0. So I know that this is not a proportional graph because it is a straight line, but it does not go through the origin. So we do see that this is a non-proportional graph, but I still need to find the slope, or I need to find that constant rate of change. And so I told you yesterday that we were going to discuss why constant rate of change is called the slope. And it's because when we're talking about slope, we're talking about like an incline, right? Or a decline. So if anybody has ever gone skiing, like on a mountain, right? An incline is going up and a decline is going down. So the slope is really how is our line increasing or decreasing as we look at it from left to right. We also, that's the first thing we need to find the constant, or we call it the y-intercept. And so I said yesterday that we're going to discuss why we call it the y-intercept in just a second. So we know that in a table, right, we figured out how to find the constant rate of change and the constant. So I could pick coordinate pairs and put them in the table and then find the slope and constant that way. But I actually find the strategy for finding slope and constant in a graph the easiest of all three types of problems we've discussed so far, right? We talked about word problems, we talked about tables, and now we've talked about graphs. So let's learn about how we find these two features within a graph itself. So I remember yesterday that to find the rate of change, we do still need to look for the change in y over the change in x. So in order to do that, we first need to pick 2 points on the line. So I'm going to erase the origin. And actually, they already gave us 2 points, so I'm going to highlight that here. Okay, and so in order to find the change in the y, I'm going to start at one of the points and start showing my jumps up or down to see how far the graph changes on the y. So I'm going to start from the bottom. I could have started from the top. It doesn't matter because the change will still be the same. And I'm going to do my jump from one corner to the next. So 1, 2, 3, 4, 5. Notice how I'm going straight up 5 jumps. So the change in y is a positive 5, right? I'm not going diagonally because I can't count diagonally how many spaces this is, but I can count exactly how many spaces up it takes to get to the next point. But I'm still not there yet because now I need to see how far over I need to get to that next point, that second point. And that would be the change in x when we look at the direction left and right. So I'm going to move over one space to the right, and I see that that's in the positive direction. So that's +1 as well, right? It's another positive movement. And so I have now found the change in y going up 5 spaces and the change in x moving over one space to the right or in the positive direction. And now let's simplify. I know that 5 divided by 1 is 5. So our slope, or our m value, is 5. Awesome. So now that we have found the rate of change, let's look for the constant. Well, I remember in word problems that the constant was the initial phi, or the starting value. And then in the table, it was the y value when x was 0. Well, on a graph, the constant is still where x is 0. It's actually going to be what the value is on the y-axis, because the y-intercept means to intersect or to cross the y-axis, right? If it was crossing the x-axis, we'd call it the x-intercept. So we don't care about the x-axis. We are focusing our eye on the y-intercept, or the y-axis. So I'm going to highlight the y-axis, and I'm going to find another color to circle where the graph crosses the y-axis. And I see that it's right here. Oh, that was a terrible color to pick. Let's pick a darker color. And a green. And I've drawn so much over here that I have to look really closely that this is the b value, the constant, right? The value that the graph crosses the y-axis, and I see that that is a negative 3. So now that we know the constant, we can put all the pieces together in our same linear equation format, y equals mx plus b. But now we know the m, or the slope, and we know the b, the constant. So let's get ready to replace those values with what we know. So our slope was 5 and our constant was -3. So we either have y equals 5x plus -3, or we can write it as y equals 5x minus 3. All right, we're going to go ahead and pause, and you can try one on your own.